Hi there. Today I'm going to tell you what to expect from solar hybrid electric pool heating. I'm Jason, the principal solar designer at Florida Solar Design Group. Recently, for those of you that don't know, we've started to recommend people use an electric heat pump coupled with solar electric panels to offset the electrical usage from the heat pump. Now, this is different from traditional solar pool heating, which is a passive system that sends water through plastic panels on the roof and returns it to the pool a little bit warmer. Solar traditional pool heating is very weather dependent, whereas solar hybrid electric pool heating is more reliable at reaching desired temperatures, and there's numerous other advantages of it. And there's downsides as well. We're not about to call solar pool heating, traditional solar pool heating, dead, but I think you should consider solar hybrid electric pool heating. And in this video, I want to show you what you can expect. So we're going to show you some real world data from some of our clients who've installed it and how their use cases are different and what you can expect in terms of energy use and your experience. So without further ado, I'm going to bring up some data, and we're going to look first at a site this is in Cape Coral, and it's a 10-panel SHEPH system, as we call it, solar hybrid electric pool heating, or SHEPH, 10-panel system. And we are looking at the array map. It shows you how much energy each panel has produced for this day. But what's most important here is the energy tab. So today, or on this particular day, February 25th, 2024, it shows the solar production for this client, and they produced 21.4 kilowatt hours. On this day, they did not heat their pool. And we're going to jump forward to the next day. Same thing. Next day, same thing. So during these days, what's happening is you're building up credits. You're building up extra energy that you didn't need to heat your pool. And those credits will just be used in the future and kind of offset your electricity usage on days that you do use the pool. So let's go forward a little bit more here. All right, here we go, February 29th, and you can see that the pool heater was turned on. Pool heating, or the consumption is in orange and production's always in blue. On this particular day, client used 46.9 kilowatt hours to heat the pool and produced 13.1 kilowatt hours. It wasn't a great solar day. And looks like the heater ran all day. It started around 8:30, ran until 4 o'clock when the pump turned off, and ran pretty much all day. These are 15-minute increments here. Jump forward another day. Same thing on March 1st and March 2nd. And then on March 3rd, the pump only ran, or the heat pump only ran until about noon. So the temperature of the pool was reached at this point, and the heat pump was able to turn off and the pool was at temperature. So for the first few days, it took the entire day for the pool to kind of heat up to the desired temperature. And I don't know what the desired temperature was for this client, but it looks like by noon on the fourth day, it finally reached that temperature that they were looking for, and it turned off. So during those days, as we go back here, you can see that they consumed substantially more than they produced in solar terms. So the credits from the prior days were being applied to these days, essentially. And it's a complete one-for-one credit. So some people are going to heat their pool every day during the season. Some people will heat it selectively. And ultimately, it just matters in total, in sum, for the whole month or for the whole year, did you produce as much solar as you consumed? So on days that you're heating the pool and the heat pump runs all day, it's going to consume dramatically more than your solar panels will produce, and that's completely normal. But remember, there's days where you produce solar power and you don't use anything, so it should all net out, and that's the idea. So when we size a system, in this particular case, we put 10 panels on the client's home. We're estimating that that's going to be roughly enough to cover the heat pump usage for the entire year. So in the middle of summer, solar panels are just producing power, and there's no usage. So you're building up a massive amount of credit. But during this time of year, February, March, April, you're typically heating the pool a lot, and you're using a lot of energy and not necessarily producing as much as you need. But in the end, it doesn't matter. It's just the net amount for the year. So jumping forward another day, okay, March 4th looks like the the heater didn't turn on until about 10:30 and then ran until the pump stopped. Same thing. March 5th, here we are today, and the pump just turned on 9:30 in the morning, and it's starting to consume power. So that's a typical use case for someone that's heating the pool pretty much every day. When they're not around or when the weather's poor, they're going to turn the heat pump off and conserve that energy, which is a smart thing to do. That's a pretty typical use case for someone doing pool heating. Let's look at another client here, also a 10-panel system, and we're going to jump back a couple days here. Let me go back and find a good day to look at. All right, let's look at these days. It looks like they used the heat pump on several days in a row. So here we go, back all the way to February 21st. Absolutely no usage for the day. They produced 24.6 kilowatt hours of energy with solar. The next day, it looks like this is probably spa heating. This is almost definitely spa heating. So they turned the spa on around 5 o'clock. It heated up, and around 6:45, it turned off. So they're using the spa in the evening hours. And then the next day, same thing. So heat pump turned on around 4 o'clock, 4:15, turned off around 6:15, and was off for the next 15-minute increment, but they were still in there, so it had to turn on a little bit at 6:45 and just kind of maintain that temperature. So it used a little energy there. Next day, similar scenario. They were heating the spa, came up to temperature in about 2 hours, it looks like. Same thing on the 25th, 26th, 27th. So it looks like this client's getting in the spa every day. And 29th here. So yeah, they didn't get in the spa for a few days. And here we go again. March 3rd, they're back in the spa again. This is a pretty typical example of the heat pump turning on and off and on and off just to keep that temperature up to the desired temperature. Again, I don't know what temperature these clients have selected as their desired temperature, but you can see the numbers at the top. So on a day like March 4th here, we have produced 12.8 kilowatt hours and consumed 7.7 kilowatt hours. So even on days when they're using the spa, the solar is producing substantially more than they're consuming. So go back another day, same thing here, 13.7 versus 9.1. And on this day, of course, no usage. Let's go back a few more days. Now here's something very curious. On this day it was 22.7 versus 12.7. But here's something that you should recognize. The heat pump uses more electricity as it is approaching the desired temperature. So this is the first 15-minute full increment. The heat pump consumed a rate of 5.3 kilowatts per hour, essentially. And then it starts going up, 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 up. And then as the spa reaches the desired temperature, it's all the way up here at 6.8 kilowatt hours. So a dramatic increase in the amount of energy required to heat water. And the reason that that happens, as the water gets warmer, as the pool water approaches the desired set point and becomes warmer, it becomes harder to heat the water. So the difference in temperature across the heat exchanger and the heat pump is causing that to happen. You need a big difference in temperature for heat pumps and any heat exchanger to work efficiently. It's called delta T. So when the pool water is cool, it's able to absorb heat from the heat pump at a faster rate, meaning the heat pump has to do less work. But when the temperature of the pool, or the spa in this case, gets near the desired set point and starts getting higher and higher, it takes more and more work to heat the pool. So when the pool is 80 degrees, for example, to go from 80 to 81, that's a lot easier for the heat pump to do than to get from, say, 89 degrees to 90 degrees. And that's evident here in all these graphs. So if I go back day to day, same thing on this day, heat pump is using more energy as it gets warmer. So that should be a real warning for people that are trying to heat a pool. I mean, heating a pool from 70 to 80 in good conditions is not going to be that energy intensive as compared going 80 to 90 degrees or from 90 to 95 degrees. Now, when you start getting your pool up to 95 degrees or your spa, it's going to start using a dramatically larger amount of energy for each degree that you're trying to heat the pool. So that's just something to consider. Obviously, we want you to enjoy your pool, and that's the whole idea here. So that's what it looks like on a daily basis, but let's look at a month. So let's take this client that's heating their pool, and we're going to look at February. So they didn't heat their pool every day of the month. So you can see on days where they did heat their pool, the energy use was dramatically more than their production. And then there's days when they didn't heat their pool at all. So if you look at the entire month as a whole, they produced 497 kilowatt hours and consumed 364 roughly. So they were actually a net exporter of power of 133 kilowatt hours. That means for the month, they produced more solar energy than it took to heat their pool. So at the end of the year, really all that matters is what's the net amount. Did you use more energy than you consumed? And it really doesn't matter the day-to-day or hour-to-hour differences. What we're trying to do here is design a solar energy system that is roughly equivalent in production to what we expect you to use on an annual basis. And that's where the number of panels comes in. So our typical solar hybrid electric pool heaters range from 6 to 11 panels. This is a little bit on the larger side. If you want the best experience and not have to worry so much about your electric pool heating costs, then a larger system is going to be right for you. And there's an economy of scale of doing a little bit larger system. Now, these systems can go larger than 11 panels, of course. These are modular. They can go up to powering your entire house. But what the idea of a solar hybrid electric pool heater is to be a replacement for a traditional solar pool heater that is just a passive mechanism. It basically heats your pool to the extent that it can based on the weather. And that's one of the huge advantages of solar hybrid electric pool heating. You can heat your pool in any condition. Doesn't matter when you heat your pool, day or night. And you don't have to plan ahead as much. You can just turn your heater on and bump the temperature up anytime you want. So a lot of advantages of going the solar hybrid electric pool heating route over traditional. But again, we're not calling solar pool heating dead by any means. There's a great use case for it. A lot of people love it. So it really comes down to your preferences and what you're trying to accomplish. So I mentioned earlier that I was going to give you a little secret on how you can get a huge discount on an electric heat pump. When we install these systems, if you have an existing heater that is maybe aging or not so efficient anymore, or maybe you don't have an electric heater at this point, what we're doing is we're giving that unit to you at cost, not charging you any labor to install it. We're taking the manufacturer's cost and passing that directly along to you. So it sweetens the deal and helps the math work so that a solar hybrid electric pool heater will be roughly the same cost of a traditional solar pool heater and make it kind of apples to apples. So if you're looking to get a replacement electric heat pump or you need an electric heat pump to make this work, we found a way to make that affordable for you and help you save about 40% on the cost of an installed system. So if you're ready for solar hybrid electric pool heating, you know where to go. Give us a call. It's not any magic here. Anybody can install a heat pump for you and put electric panels on your roof to offset your electricity usage. But we're the innovators. We are the first to market with this product, and we've done the homework. We know exactly how to satisfy our clients who install this type of system. So if you're interested, give us a call, and we'd be happy to help. Thanks.